composition of function. This is a pretty new way how to come up with a new function combining two functions or more than two functions without any algebraic operations. Let's take an example by which we can realize how composition of function or composite functions might play a role in daily life. Example: consider a function Cp. Cp be a function that calculates calorie whenever a person does P amount of push-ups. Okay, so let's suppose this is 3P. That means here 3 is the calorie that body uses whenever we do P push-ups. Calories burned by doing P push-ups. And let's suppose there is another function Pt, 20T, and this is the total number of push-ups in 1 minute, in T minutes. Total push-ups in T minutes. Okay, here you can see that Pt is the total number of push-ups in T minutes. Let's suppose if a person can do 20 push-ups in 1 minute, let's suppose in 5 minutes, then the person can do 5 times 20, which is 100 push-ups. Now, these two functions are interrelated. Now, let me ask you to interpret this thing. Cp3. What does this mean? So we want to count the calorie that is used by your body whenever you are doing push-ups for 3 entire minutes. Okay, so that means you can simply write this down as Cp of 3. Means you plug in 3 minutes in here. Okay, T equals to 3. So that is 20 times 3 equals C60. Now C60 means the person has done or completed 60 push-ups. Now plugging this 60 in this equation, we will be getting 3 times 60 equals 180 calories. So 180 calorie was used up or burned in this process of 3 minutes. So this is a nice representation of composition function. Okay, here we are not adding, subtracting, multiplying or dividing these two functions. Instead we are thinking that calorie can be counted as the number of push-ups done within some time. Okay, so we have interpreted the composition of function for one value. Now let us find the general rule for composition of these two functions in this way. So interpret Cpt, C of P of T. Okay. Then you can see that how we might want to write this would be. So always first perform the calculations inside the parenthesis. Pt is 20T. So 20T, that's the function Pt, will be now considered as a value for this function Cp, which can be furthermore written as 3 times 20 times T. Okay, thus we'll have C of Pt would be 3 times 20 is 60 times T. So the new function that we got from the composition of these two functions is 60T, which calculates the calorie that is burned by your body whenever doing push-ups for T times. Okay, and if your push-up rate is 20 push-ups per minute. So this gives a basic idea of composition of function. Now let us define the idea of composition theoretically. Interpretation of the function FOG of x. So FOG is the notation for composition of function, where we take g of x to be a value for f, right? And now suppose we have a function g from a to b. G is a function from a to b, and f is a function from b to c, right? In this case, what happens is, then if you want to find the function FOG of x, then this would be the function FOG. Then the function FOG will have domain or subset of A, and as you can see the arrow diagram, You can see the domain is a subset of A and the range will be subset of C, right? So don't confuse that. The domain would be entire A and the range would be entirely C. No, that doesn't happen usually. Okay? Now here what you can realize this is, if you take any point X in A, then Z operates with X and we'll be getting G of X in the set B. Okay, that's a range of G. So this Gx, this point, again if we operate that by F, then we'll be getting this point which can be written as F of G of X. So it will go in this way. Thus we have F of G of X will be F of G of X. So that's the interpretation of the composition of function F of G. Right? And here I can write domain of F of G is a subset of, it may be equal A, and range is a subset of set C. Okay, we must be careful about this thing.